Hey there, and welcome back to the Deep Dive. You know we'd love to take your research and extract the pure gold. And today, we're going deep on something that could totally change how we build software. LLMs. No, not llamas, though I do love those fluffy guys. I'm talking large language models specifically, how they're about to, revolutionize software testing.
It's about time, honestly. We're talking about using LLMs to automatically generate unit tests. Now, those are those individual checks developers use to make sure their code, behaves as expected.
And you've sent us some fascinating research on a new approach to this, right? Something about LLM-based unit test generation via property retrieval.
Mhm.
That title alone just screams cutting edge.
It is, it is. This paper dives into a common pain point for developers. See, traditional unit testing tools often focus on code coverage. Basically, did your tests run through every single line of your code? Sounds good in theory, right? Like you're really thorough. But
It's kind of like just checking boxes. Sure, you technically tested everything, but did you test it well? Does it actually mean the code works as intended in the real world? Not necessarily.
you got it. What developers really care about is if those tests are actually catching errors before they become a user's problem. Plus, can you even understand the tests later or update them as the code changes? Those factors are crucial for a project's long-term health.
Okay, I'm starting to see the gap here. So how does this paper try to bridge it? Give us the aha.
Imagine you're building a photo sharing app, right? You've got this function that handles uploading a picture, but it doesn't just upload. It might resize the image for thumbnails, apply filters, all sorts of things. Now think about all the ways that one function alone could go wrong.
Oh man, my brain is already short-circuiting. File type issues, someone tries to upload a 5 GB image, the possibilities are kind of terrifying.
And that's where the old way of using LLMs for testing hit a wall. They'd try to generate tests, yeah. But without truly understanding the existing code base, how different parts interact, they'd miss crucial scenarios.
It'd be like trying to write a sequel to a mystery novel without realizing the detective always leaves a specific calling card at crime scenes. You could write a book, sure, but it wouldn't have that same brilliance.
And that's where this new research comes in. They call their approach Property-Based Retrieval Augmentation, and their tool is APT. Now, instead of just looking at the code being tested in isolation, APT gets deep. It analyzes existing, well-written tests to find patterns and relationships.
So it's not just blindly spitting out code, it's actually trying to understand the intent behind the code. It's learning from the best, like studying under a master craftsman.
Exactly. Think of it like APT reads your entire backlist of mystery novels. It picks up on your subtle clues, your plot twists, your character development, and then uses that knowledge to generate incredibly clever tests for that photo sharing function you're working on.
Okay, that is seriously cool.
Yeah.
But does it actually work in the real world, not just some theoretical perfect scenario lab setting?
That's the best part. They didn't just theorize, they tested this out on 12 real-world open-source projects, meaning other developers can see and use this code. And get this, APT significantly reduced errors in the generated tests compared to other cutting-edge tools.
Fewer bugs, more reliable software. Are we saying developers might actually get to sleep at night? This could be huge. So we've established that APT is amazing and could be a game changer for developers who want to test their code more effectively.
Yeah.
But how does it actually work? What's going on under the hood?
Right. We've been talking about APT analyzing existing tests to understand the intent of the code, but it's not just about syntax. The structure of the code itself, it's about semantics, the meaning behind it, and that's where these fascinating relationship patterns come into play.
Relationship patterns. Tell me more.
The paper identifies at least 6 distinct patterns that APT is designed to find. And they didn't just pull these out of thin air. They analyzed hundreds of examples from, real projects to see how experienced developers actually write tests.
Oh, so they're like, let's see what makes the humans tick and then teach a machine to do it even better.
Exactly. And some of these patterns are pretty intuitive, structural similarity. Let's go back to your photo app. Imagine one function is saving the user's preferred image format. Maybe they like JPEGs. Another function saves their preferred filter sepia tone, let's say.
Okay, 2 completely different actions, but
But they both involve storing a user preference, right? So even though the data is different, an image format versus a filter name, the underlying structure of how you'd test that is similar. APT recognizes that shared kind of shape of the test.
so it's not just about what the code does, but how it does it. And knowing the how helps APT write better tests for completely new but structurally similar code.
You got it. And then there's behavioral similarity. This is where functions might achieve a similar outcome, but with different inputs or in like different
Okay,
situations.
so maybe one function in our photo app fetches a user's profile picture from their phone's storage. Another one grabs it from their cloud backup if they choose that option.
Totally different sources, but the goal is the same. Get that profile picture. So the way you test that is going to be similar too. Did we get the right picture? What if it's not available? APT picks up on these shared testing needs even when the code itself looks quite different.
It's like APT is building this internal library of testing strategies, and it gets better and better with each new pattern it learns.
And that ties directly into the maintainability aspect we talked about earlier, because if all your tests are well structured, if they follow established patterns, it's so much easier for another developer or even yourself 6 months down the line to jump in and understand what's going on.
That's huge because we've all seen those code bases where the tests were just a tangled mess. It's like trying to decipher cryptic notes instead of reading a clearly written report.
And it's not just about readability either. This structured approach helps prevent errors too. Remember those code style violations we mentioned? Things that technically aren't bugs but make the code harder to work with? APTs significantly outperform the competition in that area as well.
So the tests themselves are just cleaner, which for a developer is a dream come true. Did the researchers throw anything else at APT? I mean, it seems like it's acing everything so far.
Oh, they definitely pushed it. One thing they looked at was the iterative strategy that APT uses, because in the real world, you're not writing all your tests up front, right?
Yeah.
You're adding them as you build new features, refactor old code, so your test suite is constantly evolving.
Makes sense. So how does APT handle that?
It's designed to like learn as it goes. Each time APT generates new tests, those become part of the knowledge base it uses for future tests. It's a constantly growing, self-improving cycle. The more you use it, the smarter it gets.
Okay, I have to say, this is incredibly impressive. We've covered the limitations of traditional unit testing, this really cool approach with APT, those fascinating relationship patterns. But I think it's time to answer the big question. What does this all mean for you, the listener? Why should you care about some fancy new testing tool?
That's what we'll delve into right after this. Don't go anywhere.
And we're back. You know, while we geek out on the technical details here, I'm always thinking about the so what for our listeners. We've established this APT tool is amazing at writing unit tests, finding those hidden connections in code. But how does that translate into real-world impact?
It's exciting, honestly. This research, it gives us a glimpse into the future of software development. Imagine a world where writing these tests, it isn't a chore, a box to be checked, but something that actually becomes, dare I say, enjoyable, because it's so much more effective.
Okay, and enjoyable might be a stretch for some, but definitely less painful. But seriously, what's the big picture here? What changes when LLMs become this good at testing?
Think about it. If we can automate this tedious, detail-oriented part of the process and do it well, it frees up developers to focus on the truly creative, challenging, the FUN aspects of building software.
Right. It's like, if you're a chef, you probably don't want to spend all day chopping onions and destemming herbs. You want to experiment with flavors, create those amazing dishes. APT is like having a sous chef who handles that prep work flawlessly, letting you focus on the culinary artistry.
Exactly. And just like a good sous chef learns your preferences over time, APT keeps getting smarter with each new test it generates. It's this virtuous cycle where the quality of your code base and the intelligence of your testing tools are constantly improving, like in tandem.
Which means, for you, the listener, the apps you use, the websites you visit, the software that powers your world, it all becomes more reliable, more secure, potentially even cheaper to develop.
And here's where it gets really mind-blowing. If LLMs can get this good at understanding the intent behind code, at recognizing these subtle patterns and relationships, what else could they be capable of analyzing?
Wait, are you saying this could go beyond just code? That's incredible. What else could you apply this to?
Well, this research focused on unit tests, but the core principles could be applied to so much more. Think about analyzing code for security vulnerabilities automatically, generating documentation that's actually helpful, or even helping developers refactor and improve massive, complex code bases. It's about LLMs becoming, like, powerful allies in the software development process.
So it's like AKT is just the tip of the iceberg.
Yeah.
We're witnessing this fundamental shift in how software is built, and it's all thanks to the power of LLMs. It's a bit like, remember when smartphones first came out and people were like, oh, cool, I can make calls and play Snake. Little did we know what else they'd be able to do.
And that's what I love about this field. Every new breakthrough opens up even more possibilities. It's an incredibly exciting time to be a developer, that's for sure.
Yep, absolutely. Now, here's something for you to ponder as we wrap up this deep dive. If APT can learn to understand code this well, what might it be able to learn from other complex systems? Financial markets, biological data. The patterns are everywhere. The potential is truly limitless. Until next time, keep on diving up.